Okay, we are trying to solve the problem of, um, let me quickly reset this. Yeah, so the main problem we are trying to solve now is lead code number 73, set matrix zeros. Given an m by n integer matrix, if an element is zero, set its entire row and columns to zeros. So you must do it in place. The main uh, uh, twist is that we have to do it in place. The most common way to do it is we save the position of each and every row and column where we get zero. We iterate through that whole list and make that entire row and column as zero. To do that, we are using additional space to perform it. So in this current problem, what we have to do is we have to not use additional space. We have to work with the uh, space which we already have in the project. No new dynamic arrays or lists should be used to solve this. So what is the problem statement? It is that whenever this is zero, you have to make this zero zero, this element as zero, and this element as zero. If this is zero, then you have to make this element as zero, this element as zero, this element as zero, this element as zero, this element as zero. So that is the basic check which we have to do. So what are we trying to solve for now? So what we are the most efficient way to solve is using two times iterations. Basically, we go through the whole matrix twice. First iteration, what we do is we try to find all the zeros places, and if we find a zero at any place, we mark them as zero on that first. Let's say 4 was 0 here, then we mark 1 as 0 and 3 as 0. That is flagging the row element and the column element of that matrix point. Uh, Next would be, let's say, assume we have 5 over here, which is 0. It means that we have to mark uh, x is equal to 3 as 0 and y equal to 2 as 0, basically. So if we mark these two, the next iteration, what we do is we go try to find all the elements. While iterating, what we check is if the element is 0, if the parent 1 or 3 is 0, then we make 4 as 0. Let's say we have 5, let's assume that this was 0, then we have to make this 5 as 0. So that's how we iterate through the whole matrix to make the entire matrix as uh, marking them at required places as zeros. So let's try to solve this problem. So we have a test case. I think I already solved this. I had one issue with one test case, so that's why I had to rewrite it. We are using a scenario where we have it in this fashion. We have 1, 2, 3, 4, 5, 0, 7, 8, 0, 10, 11, 12, 13, 14, 15, 0. The expected output is that everything in the matrix becomes 2 by 2 matrix, n by m matrix becomes 0 other than the 3 element. So how we have to try to solve for that fashion. Now let's try to create the resolve the problem. Um, One thing which I found was, let me first take in a bowl. Uh, First, let's say first should be should be 0. Let's, let's create a bool called first column should be 0. Let's assume that it means that if we iterate that, we should make the first column as 0. Apart from this, we need int rows equal to matrix dot length, int columns equal to matrix dot 0 dot length. So how do we go about the it? For int row equal to 0, row less than rows, rows, row plus plus. The first thing which we check is that if matrix row dot 0 is equal to 0, then first matrix should be 0 is equal to true. So we assign the bool over here. Now we iterate through the columns. So how do we go about doing it? Int column equal to 1 plus then columns column plus what we checking? If matrix row, if the element over that position is equal to 0, we mark the parent as root. So we mark matrix row 0 equal to 0, matrix 0 column equal to 0. So we are marking those and we are checking if first column should be 0. We are when we are iterating, we are checking if the first column should be equal to 0. Now what we do is for int row equal to 1, row less than rows, row plus plus, we iterate through the all rows and columns. Int equal to 1, column less than columns, column plus plus. If matrix row column no, equal to 0 or matrix 0 column equal to 0. If these two are 0, what we say is that matrix row column equal to 0. This assigns in the part of it. Next, what we check is if matrix um, 0, if the first element, what we next is equal, if the first element for int column equal to 0, column less than columns, we have to make the first row basically 0. So what we do is um, matrix 0 column is equal to 0. Okay. If first column should be 0, for int row is equal to 0, row less than rows, row plus plus, matrix row comma 0 is equal to 3. Yeah. Now what we have is that we have, let me quickly test if this works out. Yeah, it seems to be passing. So what we did is we checked through the each uh, first element of the column, and if the first element of the row, if the first element of the row is 0, it means that the entire uh, first column should be 0. And what we are checking is, uh, then we iterate to the bottom of them, and if we find, we mark their starting points as zeros. Once we mark the starting points as zeros, we again iterate through the whole thing, but this time we start from the second row and second column. From there on, what we check is whether if their parents are anywhere done, they are done. If they are 0, then we mark them as 0. If they are 0, and what we now need to check is if the first element is 0. So what can trigger the first element to be 0? If uh, the only reason why first element can be 0 is if the first column should be 0, or any of the element in the first uh, animals go 0. If they go 0, if any of the element on the top becomes 0, it will become 0. So that's why we have matrix 0. We are checking whether if the first element is 0. If it is 0, then we what we do is we uh, make the whole first row as 0. Then we have a condition called first column should be 0. Here what we check is that if any element in the first column is 0, then make the entire first column as 0. So this method does it. Let me quickly add it to the into lead code and check if it works. Okay, we have this method set zeros may matrix. Right. Okay, it seems to be running. Let me try to submit and check. So yeah, it beats 27% of C# users, and I think it works, right? That's more than enough.